All right. Good afternoon, class, or good morning, whatever time it is when you're watching this video. So today we are looking at the day three material as we start in chapter two, and we're actually going to get to use the whiteboard a little bit today with the beginning of chapter two material. All right. So I'm going to go ahead and share my screen as we get started here. So let me go ahead and do that here. All right. So just reminder, looking over the course schedule, this is our day three lecture video. And so we are covering sections 2.1 and 2.2 of the textbook. There is, with this schedule, a little bit of a break with St. Benedict's Day. But then we will be back on schedule for chapter two in the coming week. And test one is also coming up next week. All right. So be mindful of that as we continue in this material. All right. So we're looking at chapter two today, and we're actually going to finally start to do some mathy stuff. So section 2.1, we already know from chapter one, data in general, we can classify into two types, where we have qualitative data, meaning it is categorical. It doesn't have a numerical value. I can maybe place it into categories according to some quality about the empirical unit we're trying to study, but it's not numerical, right? So I can't like add or subtract it. It's not a number. Okay. So when we talk about qualitative data here in section 2.1, we want to see, well, what can we do with it statistically? What kind of analysis can we perform if the data itself is not a number? Well, first we want to have some definitions to start here. We want to reference a class is one of the categories into which qualitative data can be classified. So for example, I go around asking people their favorite ice cream. Some people say vanilla, some people say chocolate, some people say strawberry. An answer to this kind of survey would be a single class. So the answer vanilla is a class. The answer chocolate is a class. A class is one of the possible categories that may result from whatever qualitative data we're collecting. The class frequency then is then telling us quite literally how frequent that class is among the data. So I collect information. 10 people liked chocolate, 5 people liked vanilla, 3 people liked strawberry. That is then the frequency of that class. However, frequency by itself doesn't necessarily tell me anything. Um, I could say, well, yeah, I'm doing a study on Belmont Abbey students for ice cream flavors. And I say, yeah, from the survey I did, 10 people like chocolate. Okay, but how frequent is that really? I mean, if I have 10 people who said they like chocolate, is that 10 people out of 20? Is that 10 people out of 10, in which case the whole class liked chocolate? Or is that 10 out of 100, in which case, well, that's actually a very infrequent answer. It has a lower frequency in terms of the entire sample. So frequency just tells us how many times an answer or a class might appear, but it does not tell us like how common that actually is in the entire sample, right? This is where class relative frequency comes into play and can be more useful for us, as the relative frequency is a direct calculation of how frequent a class is relative to the entire sample. Maybe 10 people answered chocolate, but if it's out of a sample size of 100, well, 10 out of 100, that means only 10% of the study gave an answer of chocolate. So 10 is not a big number. But if it's 10 out of 20, a sample size of 20 people, well, now 10 out of 20 tells me half of the sample responded with chocolate. So the sample size together with the relative frequency gives us more information than the class frequency by itself, right? So we have this first example here where we're given this data for different types of aphasia. Now, I'm not a biologist. I'm not really informed in this area, but we can still collect this data and talk about what it is that's happening. So I'm going to switch to the whiteboard here behind me. Let me turn off the screen share. All right. So now we're looking at the board, and we still have the textbook on the previous page or on a if you're using your phone or a laptop, just have like the textbook open on a separate tab so you can look at that as we talk about it here in the video. Okay. So we have all these different types of aphasia. These are then being classified into the types. So the class in this case is the type of aphasia. Okay. So our classes here, let's see, I want to make sure it fits on the screen. Our classes, we have Broca's aphasia. I'm just going to call it B for short, so it's easier for me. I don't have to write it all out. We have anomic. I'll call that A. And then we have conduction. I'll just call that C. So we have three different classes, three different possible responses for this survey. Each one of these classes then has a class frequency. How frequent is that response in the sample? All right, so we have a frequency for each class. We look at Broca's, we go over the sample and we count. Well, I see Broca's, let's see, 1, 2, 3, 4, 5. It looks like it appears 5 times in that sample. So it has a frequency of 5. Anomic, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 if I counted that correctly. We can double check in a moment. And then conduction, 1, 2, 3, 4, 5, 6, 7. Now that adds up to a sample size of 22. And yeah, it looks like from the table we do have 22 responses, so this should be correct. All right. So we have 3 classes, 3 possible answers for this qualitative data we've collected, where what we're collecting is the type of aphasia that each adult might have in the sample. All right. We have its recorded frequency. How many times does that class appear in the sample? But what can be more telling is the relative frequency. So the class relative frequency, and I'll abbreviate here, RELFREQ, relative frequency. All right. The relative frequency is the frequency divided by the sample size. Sure, I have a frequency of 5, but how common is that? Is that actually a common answer, or is that just, is that a small number? Is it a large number? How do we know? We have to compare it with the overall sample size. Its relative frequency, in this case, is 5 out of 22. And sure, if we wanted, we can convert that to a decimal. You can go to a calculator. And we see here we have 5 out of 22. This comes out to be 0.227. So if you convert that to a percentage, that means 22.7% of the sample had Broca's aphasia. All right, that's more telling than a frequency of 5, right? The relative frequency is telling me the percentage of the overall sample. All right, we continue. For anomic, we have 10 out of 22. And for conduction, we have 7 out of 22. All right. Now, when it comes to like these final answers, it's okay to leave it as a fraction. In fact, even on test 1, I don't mind if you leave it as a fraction like this and you even don't simplify it. That's perfectly fine. I mean, the test is going to be timed, so I realize, you don't want to spend too much time on the questions. If you can get to the correct answer, that's great. Don't worry about trying to go further. I would give this full credit on test 1, okay? Now, for the homeworks, it might be more picky about how you type in your answers. You might have to simplify the fraction or put it in as a decimal. But for test 1, we're not going to be that picky about the formatting. All right. So we have this first example with this qualitative data. where we have listed the possible classes regarding this quality, where the quality in question is the type of aphasia that we're collecting about these adults. The frequency, how often does the class appear? And then relative frequency, what percentage out of the sample does that class represent? All right. So we have that going for us in this example. Now, as we return to the textbook here, they show the same calculation here that we just did on the board. So great, we're on the right track. Now from here, I'm actually going to return back to the computer screen. So I'm going to share my screen again. Let's see, share screen. Here we go. Okay. So this is on page 33 of our textbook, where as we're summarizing, well, what can we do with this information? Well, calculating a frequency, calculating a relative frequency, fantastic way of displaying data we collect from qualitative data, right? It tells us a lot of information about just the overall frequency and the relative frequency of what we're talking about. But when it comes to presenting this information to other people, well, just telling them a number might not be as meaningful to them, in which case we want a visual or a graphical representation. For qualitative data, then, a bar graph is kind of one of the more natural ways to go about doing this, as we can create a bar graph, and we see here on the previous page, they created a bar graph representing each category. Its height is then determined by the frequency. And then we can also see, well, how tall is that frequency compared to the other frequencies? A pie chart is also a great way of being able to show this and so that people can look at it at a glance and understand what have we gained, what have we learned from the sample. All right. So we have these kinds of tools at our disposal when it comes to graphing qualitative data, where even though the data is not a number, we can still represent it mathematically so that other people can easily kind of just digest it visually based on the information we've collected. All right. So in general, when we talk about graphical descriptive methods for qualitative data, the two primary methods are using a bar graph or a pie chart, like on the previous page. Another option is called a Pareto diagram, and we have a picture here of a Pareto diagram. Essentially, what this diagram does is that it's tying a lot of this stuff together. It's a bar graph, but it also shows relative frequencies. And then we have this line in the background that's kind of increasing from left to right as it eventually includes 100% of the sample data. All right. Now, for this class, we're really not going to be so concerned with Pareto diagrams. That's not going to be important for us. But we briefly highlight it here in chapter 2, and then we'll go on to other methodologies later in the course. All right. So it's not a big deal that you remember that. It's just something that we talk about and touch on in section 2.1 here. All right. So we have that. They give some other examples here, which I don't want to go into all right now, but it's more the same kind of thing where you collect data, we can calculate their frequency. If we know the sample size, then we can get a percentage, or rather, we can find a relative frequency, allowing us to then make these kinds of charts, these tables, so that other people can more easily read what exactly have we learned from the sample data that we have collected. All right. So from here, we want to go ahead and jump to section 2.2. So let's jump there for 2.2. And in section 2.2, now we want to discuss, okay, so we looked at qualitative data. What if my data is instead quantitative, meaning it's a number, it has a quantity, it's numerical? How can I describe quantitative data in graphical methods? And on one hand, we do have some of the same tools where you could do this with a type of bar graph. We'll look at that in a moment. Another common type is a dot plot. Now for this, I think it's easier if I just show this on the screen because the sample data they're using here It is a sample size of 100. So I can't really write that on the board very easily. We'll just continue reading here from the textbook for this next example. Um, so we have this table of 100 different EPA mileage ratings on 100 cars, and they collect this data, right? Now, right now, this is a great example of the raw sample data in this current format isn't really very helpful, right? I mean, it's just a jumbled mess of numbers. I mean, just at a glance, looking at this table, I don't know, like, what's important here. Like, are some of these more frequent or less frequent than others? I don't know just by looking at it, right? So here we've generated a dot plot for the information, where the idea of a dot plot is you first have an x-axis, some kind of horizontal axis, which ranges with the possible values, the possible outputs from our sample data. We then organize it from least to greatest. So the dot plot, first of all, takes this sample we have here, which is not organized at all, and we're going to organize it from least to greatest. So, okay, that's a first good step to be able to better, more easily read what is this data. And then second, wherever we have a response on this x-axis, we're going to put a dot for one response. So we'll see here on the table, there's one dot at 30. So one of these cars, somewhere in this table, had a mileage rating of 30.0. Here it is. Oh, I can't highlight it. Well, my mouse is over it. 30.0. It's there, right? The more dots you have at a location, the more answers occurred there. So at 32.5, there's two dots. So there are two different sample points or two different cars in the sample that had a rating of 32.5. So the dot plot first organizes the data from least to greatest. And then second, the number of dots is counting the frequency for us. All right. So it's showing us the frequency for each possible class or each possible answer, and it's organized it from least to greatest. This also, you'll see a dot plot also kind of looks like a bar graph, where the taller it is at some location, well, then the more frequent that response was in our sample, or that result was in our sample. All right. So we like dot plots. They allow us to visualize numerical data in a nice kind of organized fashion, where before this table above is just kind of a disorganized mess. I can't really tell a lot about it just by looking at it. All right. But now with the dot plot, I see, okay, it looks like the most common answer here in the sample was, let's see, I don't know. That's like, if this is 35, this is 37.5. I don't know. Maybe that's like 36.9 or something. I don't know exactly what that number is. This table isn't quite that detailed, but it does show me approximately kind of what is this like highest answer with like the highest frequency resulting from the sample. All right. Another way to display this same data is in a stem and leaf plot. Now I'll go ahead and show it here, and then we'll do another example on the board here in just a moment. So a way a stem and leaf plot works is, well, just like a plant, you have a stem, and then you have leaves that are coming off of the stem, right? And so for every stem and leaf plot, it's always going to label what is the leaf unit, meaning the leaf part of your stem, what value is that number supposed to represent? For this particular graph, the leaf unit is 0.1. So this is telling me each leaf is representing a number in the tenths position, that first decimal place, okay? So when I say 30 and then 0, that's telling me that one of my data points is 30.0. We see 31 and an 8. 31 is the stem, and it has a leaf of 8, but the leaf is in the 0.1 position, right? It's the first decimal point. So that means I have a data point at 31.8. We continue. The next one we see 32.5, 32.7. If a number is repeated, that just means it appears multiple times in the data. I have 32.9, 32.9, 33.1, 33.2, 33.6, so on and so forth. And so this gives me a way of organizing the data, again, from least to greatest. But now, unlike a dot plot, this is telling me exactly what the numbers are. Before I was having to guess, like, well, what is that most common number? We couldn't really tell. But here we can see, okay, well, I guess there's a lot of numbers that appear 3 times. There's a number here which appears 4 times, 37.0. That might be the highest frequency. At any rate, a stem and leaf plot, it is kind of like a more zoomed in picture of what a dot plot is telling us. They're doing the same thing, where a dot plot doesn't tell us quite as much information as a stem and leaf plot. All right. So as an example, let's look at this on the board. Where we will see that a leaf, depending on the example, a different leaf unit might make more sense. All right, so let me switch back to the whiteboard. Okay, here we go. And let me erase what we did here with the frequencies. Now, ordinarily, if this were an in-person class, I'd be asking students for different ages. I'd like to know, well, what is the how old are students in the classroom, right? So I'm just going to make up some numbers where we can create a sample for different ages. And I'm just totally making this up. Maybe we have a class where we have someone who is 18. Maybe we have someone who is 19. Maybe we have someone who is 20. Maybe we have someone else who is also 18. Um, for myself, I mean, I'm 28, so I'll throw myself in there. Maybe we have someone who's 21. Um, maybe we have an older student. Maybe we have someone who's 32. All right. I just entirely made up the sample. Now, in this case, the leaf unit, we want the leaf unit to be, well, how far out accuracy-wise in terms of numbers do I need? For the sample we just looked at with the gas mileage, that was to the 10th place. We had like 32.8, 30.0, so on and so forth. Whatever the accuracy is going out to, that's our leaf unit. Now, in this case, these numbers I've written, I didn't write them with decimals, right? I don't know if it's like, well, is it 18 and a half? Is it 18.3? Who knows, right? So in this case, the most accuracy I have here is to the ones position. So for this stem and leaf plot, the leaf unit will be the number 1. All right, so we'll write the number 1 here. But now, if my leaf unit is the number 1, what is my stem? The stem is always 1 decimal point larger. So back in the example we had in the textbook, the leaf unit was 0.1. And so the stem went out to the ones position. I had 30, 31, 32, so on and so forth. So in this case, if my leaf unit is 1, then my stem, 1 decimal place over, is the tens. My stem are the tens. So I could have some numbers which are in the tens. I'll just write 10 as my first stem. I could have some results in the 20s, and I could have some results in the 30s. So for this stem and leaf plot we're creating, I have 10, 20, and 30 as 3 possible stems. Now, as I write out the leaves, I'm actually going to write out the numbers which occurred. I have an 8. So I'll write out 8 for the 18. I actually have another 8, so I'll write 2 8s here. There's a 9 Let's see, 18, 18, 19. The next smallest is a 20. So notice I have to write in a 0 here to indicate that there is a stem and leaf where I have a 20 and a 0 in the ones position, right? I have to write the 0 to indicate that the number 20 appears in my sample. All right, so I have to put that here. We have a 21. There's a 1. Um, and then we have a 28. And then there's a 32 down here. Okay? So you'll see from this that we're only writing in the leaves that actually appear in my sample, right? I don't have 17. I don't have 16. I don't have 22. So those numbers do not appear as leaves. I'm only writing out leaves where it actually appears from my sample. I have 18, 18, 19, 20, 21, 28, and 32. Okay? And so that's how I would read this plot as a stem and leaf plot, where the leaf is telling me, well, what accuracy, what decimal position is the leaves. In this case, they're in the ones position. So this 8 is in the ones position, this 8 is in the ones position, so on and so forth. Okay? Another thing I want to highlight here is that for a stem and leaf plot, it's possible to have a stem that is empty with no leaves on it. Come back to the textbook. So let me share my screen again. We'll share the screen again here. Look back at this gas mileage example. We have all these different data points, but look at 43. 43 is a stem, but there's no leaves in that row. Well, what is that telling us? That's showing us here then that there is no data in this sample, which is 43 point something. It just doesn't appear in the sample. It's not a response that we got. And so for stem and leaf plots, we have to write out all of the stems, at least from our minimum up to a maximum, whatever that is. But it's possible we might have in between stems that don't have any data. So 43 here, it's written as a stem, but we don't actually have any data in this sample, which has 43, right? And so this row is left blank. Even though there is no data there, we still have to write 43 to show that that is a possible stem. It's just that since it doesn't have any leaves, that tells us it's not something which appears in the sample, all right? But for a stem and leaf plot, each possible stem will still be written even if there's not a leaf that goes with that stem. So that is something you can see and run into when you're trying to read these kinds of plots. All right. Let's see. So as we continue, another big, very important type when we're talking about describing graphically, quantitative data are what are called histograms. Histograms are super, super important. And in fact, I can tell you from like here to the end of the semester, we're going to be studying histograms in some way. Okay, I'm slightly exaggerating. We will have a probability section that we will talk about through chapter 3. But once we're done with our kind of intro probability, then we will return to talking about statistics and talking about histograms. So these are going to be very important. We're going to be talking about them again at the end of the semester. There's many applications with these guys. So this is going to be important for us. What is a histogram? Well, it's like a bar graph, except instead of being a bar, which is associated with a single answer, it could be a bar which is an interval of answers, or in other words, a class interval. As I'm looking at the data with these gas mileages, well, 30 and 31 aren't really that different from each other in terms of gas mileage, right? So I might put them together as an interval and say, well, let me just count all of the data points which are in that interval from 30 to 31. All of the data points which are from 31 to 32, so on and so forth, and we will count a frequency for each class interval instead of counting the frequency of a single answer. All right. And so this results in this following picture where it's like a bar graph. It looks like a bar graph, only each bar is representing an interval of sample points, an interval of possible data responses instead of a single data entry. Okay? So from 30 to 31, 31 to 32, 32 to 33, so on and so forth. Now, the thing about a histogram is that it is entirely up to us who are doing the statistics, what size interval do we want to use? If the interval is too large, then it's not going to tell me anything, right? I mean, if I pick an interval from 30 to 44, well, almost the entire sample is in that interval. It would just be one bar, and that's not useful, right? So we want to pick a class interval which is small enough that we actually start to see some patterns in the graph. But we also don't want to pick it too small because after all, 30.1 versus 30.2, that's not that different, right? I mean, in terms of gas mileage, 30.1 and 30.2 is really not that different. We don't need to split hairs on that kind of small scale, okay? So having a good class interval can be very helpful and nice when it comes to creating histograms. We can also, when we create a class interval, we can count the frequency. We can count relative frequencies, just like we did in section 2.1, where now a class can be thought of as a range of numbers instead of like just a single number. All right. Um, So we have these different pictures where depending on, how small or how big you make our class interval, you might have your data look a little bit different depending on like how specific you're being with the class interval. And it comes down to how many classes do you want to divide your data into. In general, we have this kind of like general guideline for like, well, how many classes should I have? Depends on how many sample points are in the sample. Now, this is not like a rule that you have to memorize. This isn't something you always have to follow. This is just like a general guideline that they reference here in the textbook. Okay? Um, so they have some other examples here. But what I really want to highlight here is the summary. When we're talking about graphically describing quantitative data, one, we can make a dot plot. It's organized from least to greatest. It's representing the frequency. I can see, the different height for different possible responses from the sample. Um, but otherwise, like it's not the most detailed, so it doesn't always tell me exactly what a data point might be. So it is a little bit limited in that regard, but it is very nice visually as just a very quick and easy picture that anybody can look at and kind of understand, right? A stem and leaf display does the same thing as a dot plot, but it's more detailed in that it is listing exactly what each data point is. We saw that with the ages. We saw that with the gas mileage. As it has that greater attention to detail, it is giving us more information than a dot plot does. And it's also organized from least to greatest. Now, visually, okay, sure, maybe a dot plot is maybe more visually aesthetic. Maybe it's cleaner or prettier to look at. A stem and leaf plot, you have to know a little bit about it to be able to read it correctly, right? You can't just necessarily read it correctly without knowing anything about it. So you have to know a little bit about statistics to understand it. A dot plot, pretty much everybody, even if they've never had statistics, they can understand what a dot plot means. So there is one advantage to dot plots in that regard. Now, a histogram kind of gives us a more holistic approach where let's break up the data into intervals. I don't care about being super detailed on every single tenths position, the first decimal place, where I just want to categorize according to some interval that makes sense for what we are studying with a given sample. A histogram is generally used in most applications when we're trying to study a population of data, as a histogram can tell us overall behavior of what to expect given some variable that we're trying to study. We'll talk more about histograms as we continue through chapter 2, and then we'll talk more about them after chapter 3 and chapter 4. So they're going to be a big deal as we continue in the course. We won't see them in chapter 3 so much, but we will see them in chapter 2 and later chapters. All right. Um, so let's see. All right. So that wraps up 2.3 for us. Or sorry, this is 2.2. Yeah, this is 2.2. All right. This wraps up our day 3 material. Day 4, we will continue into chapter 2. So I don't want to like make these videos too long. I want to make sure they're kind of like nice and focused on the sections that we're talking about. Okay. If you do have other questions, please feel free to email me. Come by office hours. Let me know whatever concerns you may have. The last thing for this video, we do want to look at participation day 3. So let's go ahead and do that, where we're given this information. A sample of students are asked their age, resulting in the following data. So we have the sample. What is the class percentage, or in other words, the relative frequency? How frequent relative to the sample, or what is the percentage of that class relative to the entire sample? For students who are 18. Okay, well, first, how many times does 18 appear? So let's see. Let's write this out here. Okay. 18 has a frequency of, and I'm abbreviating frequency here as I'm writing this. But let's see. I see 1, 2, 3, 4. It has a frequency of 4. 1, 2, 3, 4. Okay, yeah, that looks good. But in order to find its relative frequency, this is divided by the sample size. What percentage of the sample is represented by this class? All right. So 18 has a relative frequency of, well, that would be 4 divided by the sample size. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 4 out of 9 for the relative frequency. Now, the last thing here, this question is specifically asking for a percentage. A relative frequency, like we did earlier on the board, can be left as a fraction, and that's fine. But if a question or like something in the homework specifically asks for the frequency, relative frequency, to be given as a percentage, then we have to give that answer as a percentage. So go to a calculator. 4 divided by 9 is 0.4 repeating, so it's got a bunch of 4s here. Or in other words, if I write that as a percentage, this is 44.44%. All right, and so that is going to be our answer for today's participation question. All right, oops, that's that. Let me use a different color. Red will work. 44.44%. That is our answer for today's participation question. All right. So again, if you have questions, feel free to email me, let me know. Otherwise, best of luck, and I will see you in the day 4 video. All right. Have a great day.